Okay, this is the physics course revision questions. I'm going to be doing the grids and tops. There, يعني, the first question is this. For they want you to describe the motion of the parachutist from the time he opens the parachute until he reaches the terminal velocity by drawing the VT graph. Okay, the parachutist once he jumps, air resistance starts acting on the parachutist, right? Because like after he jumps out of the plane. This is him. He's falling now, and there's air resistance, the drag force acting on him. So obviously, the net force that's acting on him will start decreasing. Since there's going to be drag that's pulling him upwards, the air resistance, the acceleration will decrease. A will decrease. As he continues falling, the magnitude of the air resistance increases until it's equal to his weight. So he continues falling until the drag force is equal to the weight force. And then if you watch my other recordings, this is when we say he reached terminal velocity. So he stopped accelerating at this moment and he reached the constant velocity, which is called the terminal velocity. And if you want to represent it by a graph, you put time and you put velocity. As the time is increasing, uh, the velocity will increase until he reaches the terminal velocity. Because he jumps, he starts speeding up until he reaches this terminal velocity over here. Okay, question 39. A satellite moves in a circular path around Earth. What force keeps the satellite in its orbit? Obviously, it's gonna be weight, right? Because that's gonna be pulling it towards Earth. That's the force that pulls, and obviously the weight force will always be perpendicular. I think everybody knows this, yani, by now. Grid 41. A spring has an original length of 20 centimeters. When a load of 300 grams is applied, it produces an extension of 50 millimeters without exceeding the elastic limit of the spring. What will the length be when a load of 240 grams is applied? Okay, the way I taught you guys, I showed you the same question in my recording because I told you it came in a previous AMS, and I told you in the AMS, in the exam, the answer was 17.5. The same style of question. The answer was 17.5 centimeters. Okay, the way I showed you how to do it, put 300 grams over 50 millimeters, and then put 240 grams over X millimeters. What does this mean? This means 300 grams got us 50 millimeters, 240 grams got us X millimeters. Okay, that's what I'm trying to say. So how do we know how many millimeters? You have to cross multiply, right? So you cross multiply, and you're gonna get X equals, you get 40 millimeters. So what will the final length be? So it's going to be 20 centimeters, which is the original length, plus 40 millimeters. But you can't add centimeters and millimeters. So let's convert this millimeters to centimeters by dividing by 10. Okay, you'll get 4 centimeters. So it will be 20 centimeters, 4 centimeters, which is 24, whoa, 24 cm. المهم, yeah, that's it for 41. Now 44. Question 44. Consider a bullet ready to be fired from a rifle. Denote by M and M the mass of the bullet and the rifle, respectively. The direction in which the bullet is to be shot is considered as positive. What is the linear momentum of the bullet before it was shot? They're saying before the bullet was shot. You know that the momentum P is equal to mv, right? Wait, no, that's momentum or a moment. Yeah, the momentum is equal to mv. Okay, and the moment the before the bullet was shot, the bullet wasn't moving, and the velocity of the bullet is zero before it was shot. So obviously the momentum will be zero, so the linear momentum will be zero. Assuming the bullet is fired with a velocity v, what is its linear momentum if v equals 100 meters per second and the mass of the bullet is 5 grams? You do the momentum equals mass times velocity, right? The mass has to be in kilograms, so you have to divide by 1000. Okay, so it will be 0.005. Okay, 1, 2, 3. Hey, times the velocity 100, you get 0.5 Newton meter. I think. I'm not sure. Wait. Uh, 40. Whoa. 0.5 kilo. Oh, that's a different unit. المهم, forget about the unit, but yeah, it's 0.5. But if you need a unit for momentum, it's kilogram times meter per second. Okay, because you're multiplying mass by velocity. Mass is kilogram, velocity is meters per second. Yeah, that's it. If it comes in written, please make sure to put the unit. Question 45 actually came in the CA. It was the principle of momentum. I can find the question exactly. Wait. Yeah, in the CA, it was actually the question was, and the correct blanks were the law of momentum. I think it's here. The law of momentum states that when two or more bodies interact, the momentum remains constant. The total momentum remains constant. That was a blank. Okay, provided and then blank. No external force is acting on them. Okay, those are the blanks. The law of momentum. It's not here states that the total momentum remains, and then you say constant, and then provided no external force is acting on them. Those were the blanks, I think. But please remember this law. Okay, question 46. A car of mass 800 is moving at 25 meters per second, collides with a small truck of mass 1,200 kilograms moving in the same direction at 15 meters per second. After collision, they combine and they move with the same velocity. Find the velocity after the collision. Okay, remember when you have collisions, use MAVA plus MBVB equals MAVA prime plus MBVB prime. Okay, MAVA will be the mass of car A, which is 800, times the velocity of A, which is 25, plus MBVB, which is the mass of car B, 1200, times the velocity of the velocity of car B, which is, they said 15, equals MAVA prime. So the mass of A times the new velocity, which we don't know, we're trying to find it, plus MBVB, which is 1200 times, again, the new velocity. Okay, but we're saying they're moving with the same velocity, so we can replace VA prime and VB prime by just V, right? So let's simplify this a bit. Once you simplify this left side, I'll move it down here. Once you simplify this left side, you get 38,000 equals, this is 800V because 800 times V, plus 1200V. 800V plus 1200V is 2000V equals 38,000. You divide by 2000 on both sides, you get 19. V equals 19. Let me make sure of this answer. It's 19. Positive 19. And put the unit meter per second. Okay. Question 47. A rocket engine exerts an upward force of 5 times 10 to the power 4 newtons for 4 seconds. What is the impulse? You guys know the impulse. Delta P is the impulse. It equals force times time, which is 5 times 10 to the power 4 times 4. And you should get yani 2 times 10 to the power 5, if I'm not wrong. And Newton second, because you're multiplying force times time, Newton times second. Okay, is that the correct answer? Yeah, 2 times 10 to the power 5 newtons per second. And since you have 5.0, keep it as 2.0 in your answer, okay? Question 48. A trolley of mass 10 kilograms subjected to a constant horizontal force of magnitude 20 newtons for 3 seconds. If the trolley is initial at rest, what would its final velocity be after 3? Okay, since we're starting from rest, the delta P and P will be the same. Okay, because we're starting from rest, for the change in momentum, and the momentum will be equal. Okay, for delta P will be equal to P, and we know P is mv and delta P is ft. Okay, if P is mv, which in this case is 10 times the velocity, we don't know, right? We don't know the velocity. 10 times v. It should be equal to ft, which is 20 times 3. This question, I think, was also in the quiz. So it will be 10v equals 60, and you get v equals 6.0 meters per second. Yeah, it was in the quiz. Okay, so basically they gave you points of an FM graph. Obviously you have to plot them. Before plotting any points, please make sure to set your scale. We have 1, 2, 3, 4, 5, 6, 7. Wait. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. 25, 26, 27, 28, 29, 30. Okay, we have 30 squares. Uh, so it starts at 0 0.2, it ends at 1. Obviously, you can't start your graph at 0 0.2. That's stupid. Okay, it always has to start at 0. But since it ends at 1, let's just end it at 1.2. Okay, and you have 30 squares in between. So let's take uh, 30, and you have let's take every 5 squares to be 1.2, 0.2, sorry. So 1, 2, 3, 4, 5, 0.2, 1, 2, 3, 4, 5, 0.4, 1, 2, 3, 4, 5, 0.6, 1, 2, 3, 4, 5, 0.8, and then 1, 2, 3, 4, 5 at 1.0. Okay, this is your graph, and then upwards we're gonna finish it again at 1.2. So you put it here at, wait, 1.2. Let me see what they put in their answers. They finished at 1.4. Okay, the scale doesn't really matter. You can choose. Let's say I ended at 1.2 here. At 1.2. I'll have how many squares? 1, 2, 3, 4, 5, 6, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 24, 25. Okay, 25, and we have say 5 spaces. So let's put every 5 squares to be 0 point. No, no, no. Wait. I'll take every 4 squares to be 0.2. This scale thing doesn't really matter as long as yani, your one makes sense. It doesn't have to be the same exact scale. Just make sure your scale is accurate. Because I know, because I've seen marking schemes, and in marking many and every marking scheme that has to do with the graph. Oh, I did this wrong. I think I did this wrong. Uh, Let me just continue. 1, 2, 3, 4. In every marking scheme that I've looked at, there's always, always, always marks for not having the correct scale. المهم, now I think we can graph this. The mass 0 0.2, 0 0.62, 0 0.2, and 0 0.62 is gonna be 0, 0 0.6. It was gonna be here. Okay, 0 0.74, 0 0.4. So 0 0.7, sorry, 0 0.4 is over here. 0 0.74 is gonna be over here. There you go. And then 0 0.5, 0 0.5 is over here, and 1 is over here. This is an easy point. And 1.1 is going to be 1 and over here. Yeah. Okay. Uh, these are not okay. Once you graph, I don't think it's gonna be like how my one looks, but yani it's gonna, yeah, you're gonna have a straight line or something close to a straight line. فالمهم, you just draw a line of best fits. You just draw a line in between them, something like this. Okay, my graph is messed up, but yani you have something that looks like this. Just draw a line in between them. It's called the best fit line. If you get this, yani you should get it correct. Okay. The graph obtained does not pass through the origin. I deleted the graph. I erased it. Find the value of this force corresponding to m equals 0. So I'm just going to use the line here, okay? They're saying m equals 0, so you just go to your line. Where is mass 0? It's over here. And where does that correspond the line? I hit the line, sorry. Over here at 0 0.5. So the force is going to be 0 0.5 newtons when the mass is 0 kilograms. Uh, Give one reason why the FM graph does not pass through the origin. This is the magnitude of air resistance as this before. Okay, yeah. Just say this is the magnitude of air resistance. So this could be because they're talking about the mass of the trolley, okay, and they're pushing the trolley through the room. So one reason why this might, yani, it might not start at 0 is because this is the air resistance. Because once you push like a trolley, uh, this is a trolley, you push it, there's gonna be wind air resistance acting on the trolley, right? This isn't a constant force. It's always like changing. That's why this could be a reason why this is uh uh not going through the origin, because it's air resistance. Enough yap. من الآخر, if they ask you why it's not passing through the air to the origin, just say it's this graph is for the magnitude of air resistance. Just say that, yani it's not that deep. Part C, determine the gradient of the graph. That's just finding the slope. Yani you just take 2 points, do y2 minus y1 over x2 minus x1. You don't need the graph also, you can just take 2 points here. So you can do 0.74 minus 0.62 over 0.4 minus 0.2. You get 0.12 over 2, which is 0. I think 0.6. I'm not sure. How is that? Huh? Oh, my fault, my fault, my fault. It's 0.12 over 0.2, because 0.4 minus 0.2 is 0.2. You get 0.6, 0.6. Okay, and then put Newton per kilogram, because you're dividing newtons by kilograms. You're dividing. Uh, what else? Assume that the trolley starts from rest. Calculate the length of the room. How do you do this? Ah, they're doing half 80 squared. Okay. Yeah. Uh, Honestly, this is a good question. I think this will come, to be honest. These questions could come. If not now, it will probably come in the final. But they're saying the length of the room, so they're asking for x. And if you, this is a constant acceleration. You know that the the slope of an fm graph is acceleration, because f over m equals a. Okay, this is a constant acceleration, so that means we have UARM. And the UARM formula for finding the length or displacement is x equals half at squared. Okay, so if you do it, you get x equals half acceleration, which is 0.6. Why is it 0.6? Because we found the slope, times the time squared, which is 3 squared. They gave it 3 seconds somewhere. They said it somewhere. Yeah, 3 seconds. Uh, and then x equals half at squared. You just multiply these and you get 2.7 meters. So this is يعني this question really tests you in everything. Question 50. Okay, number 50. These top questions are they're pretty annoying. Uh, the angle between there's a box placed on an inclined plane. There's two forces, weight and normal reaction. The weight is 10 newtons and the reaction is 6. The angle between the vertical and inclined plane is 53 degrees. Make a scale drawing to show the resultant force on the block. All you have to do, draw an arrow down for the weight, draw an arrow like this, sorry, no, not like that, because you know it's always perpendicular, like this, or something like that, and put normal reaction, and draw an arrow like this, which is the resultant force. You don't have to label this one. That's it. And you look, that's literally it. That's all you have to do. Okay. Part B, II. Use your diagram to find the magnitude and direction of the resultant force on the block. So you have to use Pythagoras theorem for II. You have 10 down and you have 6 up. Just use Pythagoras theorem to get this resultant force over here. To prove it, you don't need to know, but just use Pythagoras theorem. Do 6 squared uh, plus this thing squared here, x squared equals 10 squared. You get 10 squared minus 6 squared equals x squared, and you get x equals 8. Okay, and obviously it's going to be downwards, right, along the block. And most people know this. What type of quantity is force? You know, force is a vector. Why is it a vector? Yeah, because it has a magnitude and a direction. And you guys know vectors are the ones that have uh, magnitude and direction. Two scalar quantities, speed and distance, or time and mass, whatever. And vector quantities could be velocity, momentum, acceleration, displacement, and whatever you want. Everything will be correct. 51. A student wants to measure the spring constant of a spring. To do so, she attaches slotted mass to the free end of a vertical spring and measures its length. Use G equals 10 meters per second squared. The student's data is shown below. L is 12. Okay, this is the L, the length, and this is the mass in grams. Use the student's data to complete the following table relating the extension of the spring to the weight suspended. Okay, delta L will be L final minus L initial, right? أول شيء at 12 when you apply zero weight, obviously the delta L will be 0 because there's no change and you're applying 0 weight, so L final minus L initial will be 12 minus 12. That's 0 يعني. And obviously the weight will be 0. The weight, by the way, is W equals mg. Okay, now how about this one here, the second box, 13.5. We started at 12 at 0. At 0 we started at 12. Now I apply 200 grams and it extended by 13.5 minus 12. So you do 13.5 minus 12 because we do L final minus L initial. Okay, and you get 1.5. What will the weight be? You have to do mg. Okay, the mass is 200 grams. It's 200 grams times g, which is 10. but you have to bear in mind that this is in grams. You have to make it kilograms, so it will be 0.2 kilograms. How? يعني you divide by 1,000. 0.2 times 10, and you get 2 newtons. Okay, 2 newtons. The third box, 15.8. Again, you minus it by 12. You minus everything by 12. So you'll get 15.8 minus 12, which is 3.8. And the weight, again, W equals mg, which is mass 500 grams, times the gravity, which is 10. 500 grams is 0.5 kilograms times 10, which is 5 newtons. The last one, you do 16.5 minus 12, which is 4.5, and you do this 600 times 10, but this is in grams, so you have to make 0.6 times 10, which is 6. Part B, plot a graph of, oh, okay, the tables here. Plot a graph of delta L in centimeters in the y-axis and the weight in newtons on the x-axis. So you just put the weight down and delta L up, and just put some numbers on the scale and plot these points. Yani. At 0, 0, put a point. At 1.52, put a point. Here 1.52, at 3.85, and you just, yeah, you put it. And then they ask you, is there a direct proportionality between the two quantities? And justify your answer by referring to the graph. Is it directly proportional? Yes. Why is it directly proportional? Because, guys, this is a straight line over here. Okay, if there's a straight line passing through the origin, okay, then obviously it will be directly proportional. Okay, part D, use the data to determine the spring constant. Okay, the spring constant is always F over delta L equals K. In this case, just take any 2 points. The force, let's take 2 and 1.5. You can take 2 divided by 1.5 equals K, and you get 4 over 3, I think. 1.3. Yeah, 1.3. You get 1.3. Uh, Part E, can the spring constant be used to predict the extension of a spring when 1 kg of load is attached to it? Justify your answer. Okay, obviously no. Okay, because there's a limit for the spring. There's a limit for the spring. Just say no because there is a limit to the extension of the spring. That's it. You'll get a full mark. A piece of paper is placed on the turntable whose radius is 30 centimeters. The turntable initially at rest begins rotating at an increasing rate. The speed of rotation increases until the piece of paper slips off the turntable. This happens when the turntable starts making 10 revolutions in 2 seconds. Why does the particle slip? Okay, the answer here is it slips because friction becomes too low to maintain centripetal acceleration. Okay, you have the table, you place like the paper over here, it keeps on turning until it speeds up so much that the paper falls off. Because at this point, there's too little friction, because yeah, it's a paper, it's very light, so there's too little friction. Uh, that's why the particle slips, because there's too little friction. Calculate the speed of the piece of paper as it leaves the turn. The way they solve it, they find the time, because velocity equals speed over distance over time. Actually, they find the time. It's 10 revolutions in 2 seconds. It's 10 revolutions in 2 seconds. How about one revolution? So you have to divide by 10. You get one revolution in 0.2 seconds. So the time for one revolution is 0.2 seconds. How about the distance? This is a circle. The distance of a circle is the outside of the circle. This is what we call the circumference. I think you all have heard of this word before, circumference. Circumference is equal to 2 pi r. Okay? The radius in this case is, they gave it, right, 30 centimeters. For the circumference will be 2 pi times 30, which is going to be 60 pi. Okay? So it's going to be the velocity equals the distance, which is 60 pi, over 0.2. And you just do this in a calculator. What do you get? You get 9. Why is it? Oh, it has to be in meters. My fault, my fault, my fault, my fault, my fault, my fault. Okay. Back here, it's 30 centimeters, which is, it has to be in meters, which is 0.3 meters because you divide by 100. Okay, it will be 2 pi times 0.3, which is 0.6 pi. Okay, so you're gonna be left with v equals 0.6 pi over 0.2, and you just do this in a calculator, you'll get 9.4. أنا ما tweaking? Yeah, 1.8. Okay, you get 9.4. That's what you get in the calculator. Part C, Describe qualitatively how the piece of paper moves when it slips. Justify your answer. So يعني if just once you look at the answer, I think they usually don't bring these types of questions. It after it slips off the table, the piece of paper is gonna continue on the tangent to the turntable. So like if you'd have the turntable like this, and the paper slips off here, it's gonna continue in the direction of the tangent. This is the tangent. Okay, it's gonna continue and fly across that tangent, and it's gonna obviously continue with the same speed it left the turntable. Part D, ماشي في part D. 53, a student has two identical springs, each of unknown constant K. He conducts two experiments. In the first, he studies the extension of one spring by known weights. In the second, he studies the extension of two springs connected in parallel in the diagram below. Experiment 1, Experiment 2. The force extension graphs obtained in experiments are shown below. Explain how the slope of the graph helps find the spring constant in each experiment. The answer they put is they said Hooke's law. Hooke's law is F equals K times uh, K times I'd say F equals K delta L. I don't know why they say X. If you put K delta L, that's correct. Just say because it's Hooke's law and Hooke's law is F equals K delta L. So just say the slope, the K is the slope of the FL graph or whatever this graph is. Just say that the graph helps you find K because the slope is the constant. Just say that the slope is the constant of the F equals K delta L, whatever. Just say the graph helps you find the constant. It helps you find the spring constant uh, because the slope is the constant. That's it. Use the graph to determine the spring constant in experiment 1. Just find the slope of experiment 1. And look here, the slope is 250. Why is it 250? Okay, for rise. The way they found the slope, they did rise over run, which is y2 minus y1 over x2 minus x1. So it's over here. They did rise over run, which is also another technique. Rise over here is 1. The run is 0.004. Why? Because this is in millimeters. You need it to be meters. By dividing by 1000, you get 0.004, which is 250, I think. I'm not sure. 250. Why I took this goes it rises 1. You see, it rises 1 and it runs 4. Okay. I think they're gonna ask for experiment 2. Yeah, same thing. It should be the same thing. Rise over run. It rises 2 and it runs again 0.04. 0.004. So 2 over 0.004 and you get I'm not sure, I think 500 maybe. 500, yeah, 500. You get 500 newtons per meter. Part D, I think D, deduce the equation for the spring constant of the system of identical springs connected in parallel. Obviously, they're talking about the ones that are connected, which is this experiment 2. They're saying, yani, what will the constant be, this total constant? Obviously, it's going to be the constant K1 plus the constant K2, right? That's pretty much it. Since it's one combined spring, the constant will be the sum of both springs. And in this case, yani, the way they wrote it, K1 or K2, and they said the K equals sigma Ki. What does that mean? Sigma means you add, and Ki means yani however many. If it's two springs, then it's gonna be sigma. Whoa, that's not sigma. Sigma K2. That means you do K1 plus K2. If it was three springs, it would be sigma K3, which is K1 plus K2 plus K3. These types of questions, if you just put K1, K2, K3, that's just correct. You don't have to put sigma. Part E, explain why each graph bends for extensions of 10 millimeters and higher. This is easy. Just say it becomes inelastic. خلاص, it loses its elasticity. No, that's it. We go to the next grid. Question 5. Determine the magnitude of the moment of force F around point D. Since they're saying magnitude, there's no need to put the no need to put the sign or direction. I think. Let me make sure. Yeah, عادي, you don't need the direction. You just have to do F times D perpendicular. Okay, moment equals F times D perpendicular. So it will be the force, which is 4, times D perpendicular. You have to draw the line of action of F and draw the line of action of D. They're perpendicular over here, and this is 60 centimeters, but it needs to be meters, so you have to divide by 100 to get 0.6 meters. So 4 times 0.6, you get 2.4. That's question 6. Question 6 قصدي. The next grid, uh, in this case below, the axis of rotation through A is normal to the page. What is the direction of movement of F? They just want to know whether it's clockwise or counterclockwise. If I do the direction, do this, and do I'll put a different color and draw this. Okay, obviously the shorter path is the red path, which is going like this, which is clockwise, which is negative. Okay, so just say it's clockwise. It's inwards, clockwise, inwards, whatever. Question 8, let me see. Uh, the moment is into. When they say direction, they want into. Okay, just say into. If it, since we said it's clockwise, that means it's into. Question, I'll do 9. Even though it's not grid, I'll do it. Determine the magnitude and direction of the resultant moment in each of the cases. So you just have to find the moment for each one. 3 over here, let's start with 3, okay? 3, the moment of, let's call this F1, let's call this F2. The moment of F1 will be plus minus F1 times D perpendicular, right? Okay, F1, will it be plus or minus? Let's see, F1 over here to O, or F1 over here to O. Obviously it's gonna be, let me change the color. I keep on forgetting to change the color. Or it will be this blue path. Ya Allah. Or it will be this blue path over here. Obviously it's gonna take the red path, which is going counterclockwise. Okay. Whoa, that's a bad drawing. It's going like this, which is counterclockwise, so it's gonna be plus F1, which is 3 times D perpendicular. You have to look at the distance, which is in this case, yeah, it's obvious it's 2, because this is yani the line of action. This is the distance to O. This is the perpendicular. It's 2, so 3 times 2, which is 6 newtons meters. The moment of F2 will be plus minus F2 times D perpendicular. How do we do it? So it's going to be equal to, is it plus or minus? F2 again, it's like this, or it can go all the way around. It's going to be the same direction, okay? Same direction. So it's going to be plus, since it's counterclockwise. Like this, by the way, is counterclockwise. Yeah, we said it already. Plus F2, which is 2 times the perpendicular, which is 3, because you have 1, 2, and 2, which is 3. So 2 times 3, you get 6 Newton meters. Okay. So what will be the resultant momentum? Moment, it will be 12 Newton meter, because you add this 6 and this 6, you plus them. Let me check, is this correct? Yeah, 12 Newton meter. And they also wanted the direction, so you have to say counterclockwise, okay? Say counterclockwise. Why is it counterclockwise? Because it's positive. We found it's positive. This one here, 1 Newton, it's going to be like this, right? Counterclockwise. It's obvious. I don't think I have to draw the other direction. Okay, so it will be plus 1 times the distance, which is 1. This is the moment. You get 1 Newton meter, and then the other one, 2, it goes like this, or it goes like this. Obviously, it's going to be the second arrow. It's going to be clockwise. Let me use the colors like this, or it will be like this. It will be the blue arrow, obviously, because that's the shorter arrow. And that's clockwise, so it's going to be negative. The second one would be negative 2 times the distance, which is 2, which is negative 4. The total will be 3. Why is it negative? شكلي I solved wrong. Minus 2 times 2, why minus 1? Goes like this, goes like this. Yeah. Sorry, my fault. It's not plus 1, it's negative 1, because, and the KD, and then the other one will be, yeah, obviously the red path is shorter. Since the red path is shorter, for this moment it'll be negative 1. So the red path is clockwise, it's negative. It will be negative 1 times the distance, which is 1, which is negative 1. So the total resultant will be minus 5 Newton meter, and we'll say clockwise, okay? That's how you do it. Since they want the magnitude and direction, you don't put minus 5. We got the answers minus 5 Newton meter, but we want magnitude and we want direction. What's the magnitude of it? 5 Newton meter. What's the direction? Clockwise. Okay. This is how you write your answer. Question 11. Okay, 11. In the figure below, the ratio of the radius of the outer to the inner is 5/2. Complete the magnitude F for each of the two forces acting on the outer circle. So the net moment. Okay, well, yep. Okay, you have two couples. You have the F and F, and you have the 200 with the 200, right? What you have to know, the moment of any couple is Fd. And since we want the net forces of the two couples to be zero, that means this Fd should be equal to this Fd. Okay, so what do we do? So what's the moment of, let's call this couple 1. What's the moment of couple 1? It's going to be the force 200 times the distance between them, right? This is a circle, and this is the radius. What's going to be the distance between them? 2 times the radius, right? Obviously, because this is the radius. The total distance will be 2 times the radius in between these two forces. It will be 200 times 2r. How about couple 2? The moment of couple 2. It will be the force, which we don't know, yani, times, if this is the radius big R, since the bigger circle, then the whole distance will be 2r. So F times 2r. And these should be equal, right? So 200 times 2r should be F times 2r. Can we find the force? Yes, we can. We just divide by 2r on the other side. So it will be 200 times 2r over 2r equals F. You can cancel this 2 with this 2. You'll be left with 200 times small r over big R equals F. Okay, we know that the ratio of the outer circle to the inner circle is 5 over. So that means R over R equals 5 over 2. Why? Because they said outer to inner, and the outer circle is the bigger circle. The inner circle is the smaller circle. So R over R equals 5 over 2. How about small r over big R? You just flip them. It's going to be 2 over 5. So 200 times 2 over 5 equals F. And you're going to cancel 205. You get 40. 40 times 2, you get F equals 80 newtons. Okay, that's it for course revision. Good luck everybody. والله إن شاء الله you guys all do good. ما بتمنى شيء إلا الخير يعني. Good luck. Thank you for watching, and bye.